Here we're going to use SigOpt's HPO solution, and specifically Multimetric Bayesian optimization, to optimize the distillation process and perform our architecture search simultaneously. We're able to optimize for two competing metrics at the same time, and at the end of the optimization process, it'll populate a Pareto frontier. So each point on the frontier is an optimal trade-off point where you cannot improve in one competing metric without sacrificing the other. More concretely, what that means for us is that we'll be concurrently optimizing for model performance versus model size, where we want to increase model performance and decrease model size of the student model. And on the graph, we see again the baseline values for each metric that we're trying to beat. As we already know, the Squad 2 dataset is split across answerable and unanswerable questions. This just means that if the model is trained poorly, it's easy for it to classify everything as unanswerable and randomly be correct 50% of the time. We chose to set a metric threshold at 50%. This informs the optimizer to focus its efforts on parameter spaces that result in model accuracy over 50%, and we successfully avoid configurations where the model is randomly guessing. So what are we tuning? We'll be tuning training parameters, including SGD, batch size, and weight initialization. We'll be training architecture parameters, including the number of transformer blocks, the number of attention head pruning, and dropouts for the network. And we'll be tuning distillation parameters for temperature and the weights for the soft and hard target loss components. So at the end of this optimization experiment, our Pareto frontier will be optimal sets of model architecture and hyperparameter configurations, where we cannot improve in size without sacrificing performance, and vice versa. This is just an overview of our optimization cycle. SigOpt provides distillation architecture and the other hyperparameter suggestions. We create the student model and run the distillation process given these parameters. The resulting trained student model reports back its validation performance and size. SigOpt then takes these performance metrics and suggests the next set of parameters. And we continue in this loop-like fashion until the end of the experiment.